Hi everybody, welcome. We're glad you all can make it. We know there's some weather that's imminent in the area and obviously irrelevant for pretty much all of you. So we really appreciate you being able to make it here and spend the day with us. We've got really, a few objectives for the day we want to make sure we cover with you all. The first is really getting to know how to use our tools a lot better. So you're going to hear from a variety of customers from different industries. They're going to show you how they're implementing our tools for the benefit of their organizations. We've got a great presentation by Michael Stock, our Chief Lightning Scientist. He's done some interesting analysis on alerting that's going to be able to help guide how you set your own alerts. And we even have a Spheric station here. So if during breaks or during lunch you have any questions, if you want a more in-depth demo for any of the things that we're talking about, Jeff Mayerzak, our head of product, is going to be over there giving you demos. You're happy to give him any kind of feedback you want, and he can log that for us as we start thinking about our roadmap. The second objective really is to help educate all of you. Most of you, I don't think, are certified meteorologists, but you sort of probably play one at work a little bit. So Mark Hooksma is going to be our chief meteorologist, is going to do a couple of sessions to kind of educate you on, how to think about weather, what to prepare for, and really get you smarter about how you're sort of, one, interpreting weather, and also how you're communicating it back out to your organizations. And then the third is really just peer interaction. We know all of you probably learn the most from each other, the people that are living it day to day. We're always here to help you at Earth Networks, but we know sometimes you just want to hear from your peer about how they're dealing with situations. So we've got a lot of time built in for discussion and networking. We've got a little tabletop exercise for the afternoon, so that you guys can share some of the things that you're doing. But that's the day. We hope you have a good time. So I mentioned one of the objectives is knowledge and weather knowledge. So I thought it'd be a good idea to start with a little trivia. All right, and we got a little swag for those of you who, we'll say get the closest, because you may not get them completely right. Okay, so the first one is, what was the fastest wind gust that was ever recorded? You can raise your hand. I'll call on you. You can't answer. Yeah.
I think it's 260 on Mount Washington.
The miles per hour, that's close. I'll give it to you. It's 253. It was in 1996 off the coast of Australia. So here you go. Here's a little swag for you.
You have to say no rounding next time.
We might be here all day. It might take all day to do that if we did it that way. All right, so you're going to be hearing a lot about lightning from Earth Networks, obviously. How hot does lightning get? I need a number. Yeah.
Hotter than the sun?
That's true, but that's not accurate enough. We want a Fahrenheit number. Yeah. Not quite. A little higher. 1,500? Nope. Higher than 20,000. 35? Keep going. 50. You got it. 50,000 degrees Fahrenheit. It's actually 5 times hotter than the sun. So I don't know if I can reach if I chuck this down there. So we've got a hurricane coming up. What year did hurricane names start including male names? Yep.
1979.
You got it.
Wow.
You got it, Derek. Right on the money. Hurricane Bob. All right. So that's just the first of hopefully all that you'll learn today from us. So we're going to kick it off with our CEO, Rich Spalding. He's going to kick us off for the day.
Thank you, Nuge. Very kind. I wanted to start actually this morning before we kind of jump into just a couple slides, and I want to take as few minutes as possible actually this morning because it's really about hearing from you, actually, not so much hearing from us. But I did want to, could everybody just give a round of applause actually to this group, because honestly, we're partners in what we do. We actually provide, obviously, great technology and services, but in reality, we're all part of the same kind of community that we work to, and we have, I think, a shared vision, right? Our vision is to promulgate and enable a safer and more prosperous world, and I think we're all doing that, really, across our organizations and communities. So how about a round of applause for this group, and thank you for participating, for sure. And I think you all know our mission. We're doing this with you as organizations in partnership to help mitigate financial, operational, and life safety risks, utilizing our technology and unique networks as proprietary networks that augment lots of publicly available data and related services. So I'm going to talk and bring this down to a little bit a more personal level. I think a lot of this group hopefully knows that we do work in the least developed countries in the world. And we've done that in concert and partnership with the Global Environmental Fund, with UNDP, and other organizations to provide services where, in this country, we have a luxurious opportunity to have lots of data to do what we do, right? And in those parts of the world, in the least developed parts of the world, the dearth of data, right, is stark, right? And information can have significant benefits. So I wanted to share a little anecdote representative of a partnership that we established, some 3 years ago, actually. There's an organization called Viamo, and they're a global enterprise that provides information services in concert with local carriers, and they provide text-based alerting and notification and information both for health and welfare, and they also provide IVR services. And so in partnership with them, we deployed a network around Lake Victoria. Lake Victoria is an inland waterway, very dangerous actually. About 300 deaths a year occur on this particular area, and this is in sub-Saharan Africa. And this is just a quote from Ayani Bondi, right? He's a Malawi farmer, and what he's indicating here is he's gone onto the service locally with his phone and checked on the weather for the next several days. And what it's indicating is heavy weather, heavy rains and so forth. And what he did is take some action to remove his personal property from his home, right, and evacuate. And unfortunately, his home was destroyed. And so every day when we're doing our work in the least developed parts of the world, and even within our communities, we're providing infrastructure and services and data to make important decisions, right, life-saving decisions and protect property. So I just wanted to share that with you in terms of, it is about the vision, but it's also about the impact, what we do every day as service providers to our organizations and community. So, but then maybe we'll take the lens back a bit and look at this on a global perspective in terms of what does this mean to the global community. So the IPCC, which is the Intergovernmental Panel on Climate Change, does an annual report assessment on global risks across our planet. And as you can see here, indicated such that extreme weather events, natural disasters, the failure to adapt to climate change are significant risks for our global community, even higher than cyber attacks, terrorist events, other kinds of risks across the globe. So as our climate warms, this is a key risk for us on a global basis, and as it indicates here in terms of this quote from the IPCC, of all risks, it is in relation to the environment that the world is most clearly sleepwalking into catastrophe. So this is a key challenge for us, key work that we have to do across the globe. If I bring it back to our own country, and I think we've seen this certainly in terms of frequency and severity of events in the work that we're doing within our communities, over the last 40 years has been $241 billion plus disasters. And in fact, in 2017, there were north of $300 billion in damages from severe weather events. And we've seen it certainly within our community and within our regions, driven by drought and heat waves, winter storms, tropical cyclones, flooding, wildfires, severe local storms. So the challenge is real, the challenge is here, certainly right in our backyard. And so what do we do about it as a community? And certainly in partnership with the organizations that sit in this room, we're building technology and services, big data engine to provide underlying services and capability to hopefully deliver life-saving alerts, situational awareness, severe weather nowcasting. And so as I think most know, in partnership with you, in many cases our host sites for the networks and the instrumentation that we deploy, our sophisticated automated weather stations, our lightning sensor technology, Now over 1,700 sensors worldwide, excuse me, in 106 countries. We're actually doing business in almost 80 countries today, globally. And then we're adding that to what's publicly available and driving that through our big data back end, processing a business logic engine, doing data ingest, automated QA and QC, alerting, network management, analysis, derivative products, metadata handling to qualify the data, data feeds and machine learning and AI techniques to qualify that data and deliver our derivative services and outputs. We're doing 25 terabytes daily today in terms of data through our back end, almost 7 billion transactions. So tremendous back end to provide the services that we're utilizing through the products today, obviously visualizing and driving the alerts through our desktop applications, mobile applications, and online weather systems, and our outdoor alerting systems and so forth. So this is exciting for us. Obviously, we're going to talk a little bit about where we're headed in this direction in terms of technology and services, but in the end, the uniqueness of our business model also is important here. In other words, as you as clients adopt technology, both in terms of instrumentation, as our networks grow daily and annually, that becomes part of the global community and the data sets that we all leverage and utilize. In fact, as I speak to clients, we talk to clients, it's all about data that comes from their networks, but it's also the data that comes from the surrounding networks, within the community. So it is a community approach in the end, a network of networks approach for the business. And so what are we hearing from our clients, just generally speaking? Super good back, I would say, in terms of customer satisfaction, great improvement in customer satisfaction overall, and great marks, I would say, from a standpoint of where we are as a business and providing our products and services. But in the end, it's not for us to stay pat, for sure, and continuing to invest in product reliability and innovation, data accuracy, customer support, and then hopefully driving great retention rates, which have been super for the company. But really, it's about the relationship that we have with all of you and the partnership in that we deliver to our clients and organizations. So wrapping up, just to turn to where we're headed, which is where we started, which is we want to hear from you for sure in terms of the feedback on our products and services, best practices, and things we can do as a community of partners and clients. We wanted to focus on some key areas. I think Anuj alluded to that in terms of onboarding and training, kind of a feedback that we've heard from our clients in terms of beginning to utilize the tools and technology to the greatest advantage. And then in terms of alerting, continue to advance our capability there and extend that, important obviously in terms of delivering that key value proposition. And then in forecasting services and technology, and being able to provide services around that, improve services. So those are a couple of key areas that we'll focus on today and speak to and hear from the audience as well. So with that, enjoyed meeting everybody quickly this morning. Hope to spend more time with you today. Thank you again for participating. Really appreciate all you do with us and our partnership.
Thank you, Rich. All right, so we're going to get started with John Patrick. So our first speaker here, John Patrick, is likely one of the few here this morning that's traveled north to get here to Orlando. He's the chief meteorologist at WZVN in the Fort Myers and Naples market. JP, as his viewers call him, is in his 14th year at ABC7, but also worked in Arkansas, New York, and his home state of Pennsylvania prior to moving to Florida. He was the first in Southwest Florida to earn both the Certified Broadcast Meteorologist designation from the American Meteorological Society, along with the seal of approval from the National Weather Association. He's been nominated for 3 Emmy Awards and won 11 Associated Press Awards. For the last 6 consecutive years, independent research company Weather Rate has ranked ABC7 as Southwest Florida's most accurate forecast, highlighting how ABC7 tracks Southwest Florida weather and extreme events using Earth Network's data. Here's John Patrick.
Thank you, Anuj, and good morning, everybody. I'm going to be very unprofessional here because I thought this was going to be a great spot to have. I'm going to do a Facebook Live for everybody back in Southwest Florida, and I thought that would be a great spot right there by the podium, but we can't see. We can see the speaker, but we can't see what's up there on the screen. So I'm going to set it back here. That's better. And now I'm going to hit live. So nobody curse, okay? So do we have anybody else here from Florida other than me? Oh, you're all from Florida? So you all know that we've got a little storm headed our way, right? So I thought, well, I'm going to talk about how we use Earth Network's data to track everything from cold fronts to sea breezes to hurricanes through southwest Florida. Wouldn't it be great if we had a hurricane barreling down on us? We're all in the cone, like the entire state is in the cone. So, we're all just kind of waiting with bated breath to see how this thing is going to behave, and hopefully it'll stay a fairly small storm and not be too bad. But in southwest Florida, in our viewing area at ABC7, we have over 1 million adult residents, 18 plus, and that has grown. I started at the station in 2005. We were market 64, I think. And we have grown. We're now market number 55, so our 6 counties include Collier, Lee, Charlotte, DeSoto, Glades, and Hendry. That area that's highlighted there in the box, that's what we call Southwest Florida. And we have a very muggy climate in Southwest Florida. Some locations farther south, like around Naples and Marco Island, are a bit muggier than the rest of Southwest Florida. Summers are usually somewhat wetter than winters, much of the rainfall coming from convectional thunderstorm activity. Tropical cyclones also enhance our warm season rainfall. We're probably going to get 2 to 3 more inches of enhanced rainfall from a tropical cyclone heading into next week. The coldest month for Southwest Florida is usually quite mild, although frosts are not uncommon. We get those on occasion. And winter precipitation is derived primarily from frontal cyclones along the polar front. So we do get some cold blasts now and again. Our average yearly temperature at Fort Myers is 75.1 degrees, and the warmest month, which is August, 83.4 degrees Fahrenheit when you average out the high and the low temperature. Our coolest month on average is January at 64.2 degrees Fahrenheit. That's not bad. You didn't hear me talk about snow anytime, did you? The last time it snowed was actually Christmas Eve, 1989. We had snow flurries at Pagefield and Fort Myers. Hasn't snowed since then. We get a bunch of rain, especially this time of the year. This is our rainy season. The average yearly precipitation in Fort Myers is 55.9 inches. That's 4.66 feet of rain each and every year. And if you need to envision that, you remember the show Different Strokes? That's the height of Gary Coleman. 4.6. Google it. Somebody out there is Googling it right now to see how tall he was. The wettest month on average is June, the very start of rainy season. We get a little over 10 inches of rain. The driest month on average is December at 1.7 inches of rain. You know, when I moved to Fort Myers, I lived in Arkansas for 2 years, Tornado Alley, and I grew up in Pittsburgh where we get lake effect snow, and then I lived in New York where we had, I think, a blizzard or two while I was there. So when I moved here, everyone's like, oh, it's going to be sunny and 78 degrees all the time. You're going to have such an easy job. Well, this is all the stuff that we track in Southwest Florida. Fronts, sea breezes, brush fires, heavy rains, thunderstorms, tornadoes and water spouts, excessive heat, frosts and freezes. Oh yeah, and there's a tropical storm and a hurricane a couple times a year in there as well. And all the times of the year that we track all of that stuff. Yes, we do track sunshine as well, and we have some of the most gorgeous sunsets you'll ever see. This is from one of our Earth Network's cameras. This is actually at our television station. So we're looking from the studio off to the west. That's the Caloosahatchee River that you see there. On the other side is Cape Coral. And you see how that sky is all nice and orange? That's because of some Saharan dust that comes from the Saharan desert, floats every now and again all across the Atlantic Ocean, and dots our sky in southern Florida and gives us these gorgeous sunsets that you see there. Earth Network's data is very valuable to us on a daily basis at ABC7. It's real time. It's updating live on the air as the conditions change. So if I'm showing the stuff on the air, you'll see the temperature, you'll see the wind direction, whatever I'm showing. As it changes in real time, it's updating on the air. This obviously was not taking from this time of the year with a dew point of 50. The dew point's like 1,000 right now. But this is from Campo Felice, one of our kind of newer cameras. I think we've had it about a year or so now. Campo Felice is a high-rise right on the Caloosahatchee River. That's the Caloosahatchee, again, we're looking at in US 41. North Fort Myers is on the other side. But we get a great view from all directions because this thing is so high up. So that's one of the Earth Network's cameras. We've got temperature and dew point there. A nice nice north-northwesterly wind, keeping that dew point low, obviously in the wintertime. And so the feels-like temperature matches the air temperature, which I would kill for this time of the year at 69 degrees. That's not going to happen for a few more months. So that's how we kind of use it on a day-to-day basis when we're not seeing much weather. But we also use all this data that we're getting in from Earth Networks to track specific events through Southwest Florida. And again, it's all live as the information changes on television. In the wintertime, we track fronts, cold fronts. And as a little explainer, since I was speaking with Anuj, and I said, what kind of a crowd are we going to have? And he said, there are some meteorologists, but not too many. So we're going to explain some of these weather phenomenon here as we go through time. So a cold front consists usually of a low pressure system, a little storm system, and then usually a warm air mass out ahead of that low, and then a cold front with colder air trailing behind it. So we get a warm southerly push of wind ahead of that front, and a northerly, cooler, less humid push of air behind the front. As the front drives into Southwest Florida, in our case, it comes in, and what it does is it actually lifts the warm and moist air out ahead of it. Humid air is more buoyant. It rises more easily than the denser, colder air that comes in behind the front. So as that air rises, it condenses, and that's how we start to see clouds and showers and thunderstorms out of the front. So those warm air molecules are rising, and you'll start to see some of the clouds form as that condensation starts to happen. The rain and the thunderstorms will form along the front. If that process is strong enough, we can get strong to severe storms. Sometimes even a squall line, a line of thunderstorms with some gusty winds will push through. A lot of times this will happen during the winter months in Southwest Florida. We can actually track that using some of the data that we get from our Earth Network sensors. On ABC7, we call it the Neighborhood Weather Network. So that's what we're looking at, but this data is all coming in from Earth Networks. You see the wind component, the front is about halfway through the area at this point. Some locations are reporting a northwesterly wind where the front's already gone through. We can track places like Naples with that west wind at 5 miles per hour, and some locations with a southwesterly wind, we know the front has not gone through yet. After the front passes, you can see all of the wind directions are coming from the north to northwest. And when we see all the locations with that same wind direction, we know that the front is all the way through Southwest Florida. Again, with a dew point of 44 in DeSoto County at Arcadia Senior High School, we know this was not this time of the year. This was a winter event. But we can show wind direction, wind speed, the gust for the day, the humidity, the dew point, and the feels-like temperature all on one screen. And again, that all updates in real time as those weather conditions change. Another thing that we have this time of the year is our summertime sea breeze in Southwest Florida. Over land and over the water, usually in the morning, there's a slight difference, but the temperature starts at about the same. So in this example, we have the temperature over land at 78 degrees, the temperature over water, the Gulf of Mexico by us, at 79 degrees. So as the sun comes up, we start to heat both the water and the land, but the land heats more rapidly, more efficiently than the water does. So by the time we get into the early afternoon, we'll see a temperature about 90 over the land. The water temperature is still about 79, maybe 80 degrees. So there's about a 10 or 11 degree difference in the temperature. That heat causes the air over the land to rise. And as a result, we start pulling in some of the air from the Gulf of Mexico, which creates a boundary. That sea breeze boundary will push in. That's where the two wind fields, usually there's an offshore wind to start the day before this process begins. So right where that boundary between the east wind and the west wind meets, that's where the sea breeze is. It'll be very warm east of that sea breeze and a bit cooler to the west of that sea breeze. Right along the sea breeze boundary, that same process, kind of like a front, happens where that warmer air rises, it condenses and cools. You'll see clouds start to build early afternoon in our inland communities right near that sea breeze front, and then we'll get afternoon and evening showers and thunderstorms when we don't have tropical cyclones approaching. This process is not happening right now in Southwest Florida. Again, this is one of the Earth Network's cameras that we have. We've had this one forever. This is one of my favorites, though. That's Naples Bay that we're looking at. During Hurricane Irma, by the way, this was mud. This whole thing emptied. But you can see that line of thunderstorms coming in, developed along the sea breeze inland, pushed back towards Naples Bay. And it's a fairly quick process. Usually these storms last about 30 to 45 minutes and then they're done. So even though it rains in Southwest Florida almost every day, it doesn't ruin your entire day. This is a camera that we have from the Naples Grand Beach Resort. We're looking out toward the Gulf of Mexico, out towards the southwest. You can kind of see the sunset off there in the distance, and again, some of those sea breeze thunderstorms racing out toward the Gulf of Mexico with a quick downpour. Lightning, we track all year round, both with those cold fronts and with the sea breeze thunderstorms in the summertime. And the process, again, we start with this warm, kind of humid air, and it starts to rise over the land. And as it rises, it cools and it condenses. And after that process goes enough, we have the wind producing some water droplets. And if it's cold enough up in that cumulonimbus cloud, that's what that cloud's called, we can get some ice pellets, which could possibly be some hail as well. That process, though, that collision process creates a charge within the thunderstorm. So we have these positive and negative charges within the thunderstorm cloud. Underneath the thunderstorm cloud, there tends to be most of the time a positive charge near the ground. It's not 100% the case, but more often than not, it's a positive charge. So those two different electrical charges creates the lightning that you see. What happens is between the negative and the positive at the ground, and you'll see this happen within the cloud as well, the energy from that negative charge meets the leader from the positive charge either up towards the top of the storm or in the ground. The cloud to ground lightning, you see, is when that process happens between the cloud and the ground. What some people call heat lightning, which really isn't a thing, it's just cloud to cloud lightning, is the same process happening between that negative charge and the positive charge just within the cloud. It's actually not coming to the ground. Sometimes this can happen, I've tracked on our live Doppler radar, 10 or even 12 miles away from where the actual rain from the thunderstorm is. You can get a lightning bolt, and we call that bolt from the blue, if you've ever heard of that. You can have a mainly clear sky and still get a lightning strike because of the edge of the storm being far away from the rain, and sometimes those are the deadly strikes. We've had a few people, knock on wood, we haven't had any recently, but over the years since I've been there, we had a few deaths from lightning strikes. And since Earth Networks came out with their lightning data a few years ago, a lot of our parks around Southwest Florida, a lot of our high schools have installed the lightning detection system from Earth Networks, and if there's a lightning strike, you're waiting 30 minutes. And if it gets to 29 minutes between strikes and there's another strike, the clock resets 30 minutes. And I think that's really, really helped a lot for us in Southwest Florida. Well, I don't know what this slide's supposed to be, so let's find out together. Oh, here we go. So this again is our Earth Network camera at the station, tracking some of the lightning strikes that we're showing in real time. I think I was doing a Facebook Live with this camera. Heavy rain. During rainy season, we can sometimes get 5-6 inches of rain out of one summertime thunderstorm that moves through Southwest Florida. We have a camera from Southwest Florida International Airport, and we've recently, about a year or so ago, I guess, got the ability to display these cameras through our Barron weather system. We have our weather graphics is through Barron Services. They developed the Doppler radar that all the National Weather Services have. We have their Doppler radar as well. And these cameras, you can see if you're looking at the vehicles, that looks like it's live, real time. It doesn't look like a webcam at all. Some of these cameras look fantastic. You can also see some of the heavy rain that's happening there at Southwest Florida International Airport. We have any Boston Red Sox fans here in the room? A few. A lot of you are from Florida. But we have spring training from Boston Red Sox each and every year. This is actually JetBlue Park. We have a camera there, one of the Earth Network's cameras and weather stations. We're looking towards, you see the cars up towards kind of the top center of the screen there. That's Daniels Parkway. They're actually building on the other side of Daniels there. You can kind of see a road with no traffic. They're building a new road that goes from JetBlue Park, Southwest Florida International Airport's off in the distance. So I think at the start of next spring training, they're going to have a new roadway that goes from the airport and it dumps you out right there at JetBlue Park, so it's going to be real easy. But we've seen some heavy rain events on that camera as well, to the tune of a few inches out of one of these storms. And how that happens is when we have that thunderstorm, we talked about it forming, after a while, if a storm is slow moving and it sits over one location for a long time, sometimes when that sea breeze develops, there's no wind above the thunderstorm to steer it around anywhere. So we can get these microbursts as well. So we get heavy rain and we get big winds. There were 2 days in a row let's see, today's Thursday, Monday and Tuesday, 2 days in a row. There weren't very many storms over southwest Florida, but 2 microbursts were right over my house. So we've got this heavy rain, and again, if it's cold enough, we can get hail out of that thunderstorm. After that stuff sits up there and grows large enough, the water molecules and or the hail, gravity pulls all that stuff down. That's when we see the rain. And along with that rain and hail, you can sometimes get big wind gusts to the tune of 40, 50, sometimes 60 miles per hour out of one of these downbursts. That downburst on a day when we don't have any steering wind in southwest Florida, that spreads out in all directions, and sometimes that is enough to make new thunderstorms. You get that warm air to rise. So here, out of one thunderstorm afternoon, some of the wind gusts we got. Again, this is not severe weather. This is just some of these downbursts that have happened around southwest Florida. Naples, the biggest one there at 47 miles per hour. And in one fell swoop, one of the elementary schools in Fort Myers got over 2 inches of rain. And sometimes we'll see localized flooding in some of the poor drainage areas. Dangerous heat is another thing that we track during the course of the summer. This is probably more like what we're going to experience today, that dew point in the mid-70s. Probably not quite 95 degrees, but when I made this graphic, we were in the middle of getting several days in a row very close or slightly above 95 degrees. Dew point is 75. That gives you a feels-like temperature of 107 degrees. So moist air limits evaporation off of your skin, which makes you very uncomfortable. And so that's why we have heat advisory sometimes issued when we see those heat index values get up to 105. This particular afternoon, we have about 90, 91 degrees. Naples, Hamilton Harbor Yacht Club's right on the water. That's why it's a little bit cooler because of that sea breeze has passed through there already. But look how humid it is. We've got about 70 to 80% relative humidity in there, along with those temperatures in the upper 80s and low 90s. So that's actually how it feels out there. 108, 105, 106. We had heat advisories out for this particular afternoon. We also can use Earth Network's data to verify events that we have going on here in southwest Florida. And again, this is all done in real time. We've got a live radar that the sweep updates live on television, and we've got Earth Network's data that's updating in real time, so we can use one to verify the other. This is a day where we had some rainfall around southwest Florida. Pay attention to that 0.90 there. That's a town called Bonita Springs. Estero about 1.2, Naples about 1/3 of an inch, Cape Coral about 1 inch, and on our Earth Network's Neighborhood Weather Network, you can see there Bonita Springs 1.05, so we had 0.9 on the Doppler radar estimate, so that's not too far off. Fort Myers 1.19, Naples 0.8, and about 2/3 of an inch there at another location in Fort Myers. And that's another thing that's nice about having all this data all over southwest Florida. I don't know how many stations we have offhand, but it's a lot. Like we've got all 6 of our counties have several stations. So we've got 2 locations in Fort Myers. They're in different parts of the city. But you see, one's got almost 1.2 inches of rain, and Villas Elementary School there has 2/3 of an inch. So a very big difference in not a large area, and that's what we will sometimes have with some of these localized thunderstorms. Some of the rain that we got that particular day, about 1/2 to 2/3 of an inch. In those locations. We are also able to go back and look at rain totals for an entire month. We can go back and look at 2-day rain totals if we have an event that spans more than 1 day, so that's always nice to have as well. As I mentioned, we can verify what's going on our radar using the Earth Network's data that we're getting into the station. So this is Captiva Island in Lee County. If you've ever been there, it's gorgeous. Where I've got 2.6 miles, there's a downpour there out in the Gulf of Mexico, and where I'm drawing that marker from is South Seas Island Resort on Captiva Island. It's right there on the tip of the island, and we actually have 2 cameras there. We have one at the pool and one at the beach, so we get 2 gorgeous views. This particular one, I'm using the beach cam because it's pointed out toward the Gulf of Mexico, and what I just showed you on radar, I pulled the camera up and I'm able to see, yeah, there it is, right there off in the Gulf of Mexico. And if you pay attention, those people are also seeing that shower off in the Gulf of Mexico because, look, they're grabbing their chairs and they're heading back inside wisely. I didn't see any lightning in this view, but I guess that rain shower off in the distance was scaring those people to come on in wisely. And the last thing that we track in southwest Florida that's a major event for us, hurricanes. We are, of course, right in the peak of hurricane season. The peak is actually September the 10th. And how a hurricane forms, I mean, this is relevant because we got one in the Atlantic Ocean, for heaven's sakes, barreling towards us. So we need water temperature of about 80 degrees or warmer. In the Atlantic right now, where Dorian is, it's about 83 to 85 degrees. So we got plenty of heat there. We've got a moist air mass, a lot of humidity out there. And we need light wind shear. So when you're trying to form a thunderstorm or a hurricane, which is basically forms out of thunderstorms, you need light wind above that vertical development. Because if you have wind to blow it apart, it's like when a kid builds a sandcastle, or if you build a sandcastle out at the beach, and then you've got a kid, the kid will be wind shear, comes and kicks it over, well, that sandcastle's not in the vertical anymore. It's smashed over. That same thing happens to hurricanes when there's wind shear. So hurricanes like areas that do not have wind shear to keep them from growing in the vertical. So as the vertical development happens, that air is rising within those clusters of thunderstorms that are forming. So that air has to be replaced. So it gets pulled in from all directions. It starts spinning. The low pressure or the tropical cyclone starts to spin. And it will eventually, if the conditions are right, become a tropical depression or a tropical storm. Our biggest one, let me go back here. Our biggest one was Hurricane Irma recently. That was 2017, 2 years ago. It happened right on the peak of hurricane season, September the 10th. That path that you see there is just about exactly the same path that Hurricane Donna took in 1960. And we had a Lee County commissioner whose name is Frank Mann. He would always, when I would do hurricane seminars with the Lee County emergency management folks, and if he was at one, he would tell me the story about how Donna back in 1960, before the I crossed Fort Myers, it emptied the Caloosahatchee River. He was just a kid and he walked across the river. You can walk it, it was just mud. Then, of course, when you got the backside of the storm, all that water and then some came back. This same thing happened with Hurricane Irma, not to the Caloosahatchee, but out of Fort Myers Beach. The pier goes out about 150 yards. The water was pushed all the way out past the pier. Naples Bay, which we saw the Earth Networks camera, that was emptied. That was mud. You could walk across it. The Caloosahatchee didn't go all the way empty, but it went way down, and the boats were in the mud there. So that same scenario happened again with Hurricane Irma. It was a Category 3 storm, 120 miles per hour. When a hurricane strikes southwest Florida, we have a sister station in our building. We're run by Waterman Broadcasting. There's two stations run by the same company in one building. Our studios are side by side. When a storm comes through, we simulcast. So we put both channels with the same programming, and we combine resources. Between our two television stations, we have 9 meteorologists. So that's pretty good. When you're on wall-to-wall coverage, you can rotate people in and out. That also means we've got 2 computers to show Earth Networks data around the area. So one of the things that we also like about hurricanes and covering hurricanes is we get to sleep at the television station for at least 1 or 2 nights. This is behind a big monitor I'm going to show you. This is in our ABC7 studio the night before Hurricane Irma. I thought it was a great location because nobody knew about it. It was right next to the Weather Center, but what I forgot to figure into my sleeping equation was that there were going to be people going in and out of the studio all night long. So I got upgraded the next night to one of the offices upstairs. You know, it's like when you go to the hotel room and you go, this something wrong with my room, and you get upgraded. So I got upgraded to the programming office the next night, and I slept on the floor up there. That's in the ABC studio. That's on the front side of that monitor that I just showed you that I was sleeping at on Saturday night. That's Robert Van Winkle on the left, and of course me on the right there, tracking Irma as it approached southwest Florida, both on ABC7. That's the ABC7 studio. This is the NBC2 studio. We were having a meeting switching between the morning and the evening shift of meteorologists. We had one meteorologist who started 2 days before Irma, so we couldn't put him on television because nobody knew who he was. So he was kind of manning the computer and the web and the internet, answering emails and all that kind of stuff. But we had 4 meteorologists on a 12-hour morning shift and 4 meteorologists on a 12-hour evening shift. So we were able to rotate out, and when we would change shifts, we would have a little powwow just to make sure everybody was on the same page and we weren't telling 2 totally different messages. That's the eye of Irma, south of Marco Island. Again, it made landfall, 120-mile-an-hour winds. That's the storm making landfall Sunday at 3:35 in the afternoon on Marco Island. And here's how ABC7 and NBC2 used Earth Network's data to track the first major hurricane in southwest Florida since Wilma in 2005. We had Hurricane Charlie in 2004, then right after that, the very next year, we had Wilma, which also made landfall not too far from Marco Island, Cape Romano in Collier County. But Irma just went right through the entire viewing area. Charlie cut through Charlotte County and across the state, across the peninsula, kind of west to east. Wilma kind of went southwest to northeast, but Irma made landfall on Marco Island and went due north. So there was nobody in southwest Florida, and since it was such a large storm, nobody really in Florida that didn't see some effect from Irma. So that was a really big deal for us. I'm going to show you, wrap up here with a video of some of our coverage using some of the Earth Network's data here. And again, you're going to see two versions of the Earth Network's computers that we have. They call it on NBC2, they call it Weather Now, we call it Neighborhood Network, but it's all the same thing, it's just branding. And you're going to hear us call for AWS a lot. We would have to call for, we'd tell the directors, okay, we want radar. We would just call for it live on the air because we're on the air constantly, so we don't have any way to have a rundown or program our stuff. So we're just calling things out. So you're going to hear us call for AWS, which is the Earth Network's computer. And it's AWS because back in prehistoric times before I started there, it was Automated Weather System. And so that's what the directors call it. Ooh.
Here toward the Keys, and you can see these little anemometers really coming up. Key West, 31 mile per hour winds, gusting to 41, and toward Alamorada, 45 mile per hour winds, gusting to 54 already. And in Key Largo, it is now an east wind at 52 miles per hour. The storm is still 100 miles away from the Florida Keys, and it's already turning into a tropical storm down there. Remember, when we're talking about winds, you're going to hear us use the term sustained winds, and you'll hear us talk about wind gusts. Sustained winds are just what the word implies. It goes on. It's a continuation of wind speed over a minute and more. A gust of wind is a wind speed that only lasts a minute or less. All right, so sustained winds down already in Florida at tropical storm strength. Here's John Patrick, ABC7.
Robert, I wanted to show you, and a lot of us were on our WeatherBug computers here looking at the sunset, and I just want to show this kind of in a time-lapse form. And in fact, I'm going to step out of the way here because this will take your breath away. Watch this. The last sunset before Irma. And right now we're looking at northeast winds, 14 miles per hour at Cape Coral High School, 32 mile an hour gust, and these winds are going to start picking up as we go through the evening here in southwest Florida. East wind at 15 miles per hour. At Sanibel right now, 33 mile per hour wind gust, and a 35 mile an hour wind gust over at Lake Okeechobee, our weather station there in Clewiston. Here are some other winds. These are current winds around southwest Florida right now. Punta Gorda, a 20 mile an hour wind out of the east-northeast, and we're seeing about 10 to 15 miles per hour at Fort Myers High School. The wind a little bit calmer there. Here are some of the gusts so far today. Between 45 and 50 miles per hour, really. The biggest one so far at the Naples Airport. We have a couple of sensors there. We have our live sensor and the airport sensor, both right near that 50 mile an hour mark. Over in Hollywood, 46 miles per hour, and in Fort Myers, 44 miles per hour. So it is getting gusty, and these gusty winds will continue to increase overnight. Now, over on the East Coast, in Fort Lauderdale, already an 80 mile per hour gust this afternoon. Dania Beach at 70, Marathon and Fort Lauderdale at 66. And, you know, we're talking about these winds picking up, and that will continue to be the case as we go into the overnight and this hurricane gets a little bit closer to southwest Florida. AWS. There we go. Thank you. In Naples, as you would expect, some of our southern locations have seen some of the biggest wind gusts, and at the Naples airport, we've already seen hurricane force wind gusts. The wind right now is 36 miles per hour. The gusts are up to 82. In Fort Myers at Gulf Harbor, again right on the water, a 69 mile an hour gust. Winds coming out of the northeast and east. That wind direction is also very important because that's what is currently... Thank you. That wind is what's currently pushing the water out of the Caloosahatchee and all the canals and waterways out toward the Gulf of Mexico. It's this northeasterly wind direction. As the storm approaches, the wind direction is going to stay from the east to northeast. Now, as the storm moves north of our area, you're going to see this wind direction come around from the exact opposite direction, from the west-southwest. And that's going to take all the water that's been pushed out of the rivers, and it's going to bring it back. And it's going to bring even more water, likely, than what was in those waterways to begin with. So that's what's going to cause the storm surge a little bit later on today.
A wind gust of 103 miles per hour at Naples. There's going to be some significant damage in the Naples area, and it's going to start right now. The winds are gusting already at 103 miles per hour. Naples, and I just have to broad brush this, the entire area from the beach all the way to Golden Gate Estates and Golden Gate City. Everybody in the Naples area, get in your cover now, get in your shelter now. It's time to do it.
This, of course, you'll know is downtown Fort Myers, the River District. We've kind of flipped the camera back around from kind of the opposite direction from where it was. Now we're looking, that's the basin right there. And I picked this direction because it's a little bit more protected from the wind and the rain. I had to reset the camera here because you can see it's as the raindrops get on the camera lens, it gets fogged up. But you can plainly see there those trees blowing around in the rain. And again, that 103 was at 12:58 at Naples Airport. But Fort Myers, we had an 88-mile-an-hour gust at the Gulf Harbor Yacht and Country Club, 88-mile-an-hour gust at Collier County Emergency Services, and also the Golisano Children's Museum just after 2 o'clock, an 87-mile-an-hour wind gust.
So 103, 88, 87 hurricane force winds, and the sensors are still working. So some of these sensors really have been resilient throughout Hurricane Irma. You may have heard that the Naples Airport recorded a wind gust of a 142 mile per hour wind. The National Weather Service sensor there went offline during the hurricane at some point. That 142 mile an hour sensor was from the Earth Networks sensor that was recorded there. So we were very impressed at how well that one, and I mean, that River District camera, I was just shocked that one stayed up the whole time because we were losing power. And usually that's one of the first locations to lose power as far as our cameras go, but it held up really well, and a lot of our sensors held up during the storm as well. If they went down, it was either because the internet service went down or because of the power at the facility where the station's located went down. But these things held up really well. We're recording 100+ mile-an-hour winds. So that's all I have for you. Hopefully you learned a little bit about how we use all this data on television to cover weather from day to day to severe weather events. Anybody have any questions? All right. Oh, you do.
You did say that gusts are less than 1 minute, correct? So there's gusts.
Yes, gusts are about a minute or less. Sustained wind is longer. It'll go for more than a minute.
And always when you mentioned the winds, they're always from the direction it's coming or the direction.
The wind direction is the direction from which the wind is blowing. So when we say an easterly wind, that means the wind is blowing from the east. Yes?
During a hurricane, our weather guys on the East Coast, they roll up their sleeves and take their time.
I know. I saw one here last night do that. I'm not going to lie. You know, in a situation like that, in a hurricane, you know it's coming. You can take the time to put your jacket on. There are times when, you know, if I'm in the weather office and we get a tornado warning, I think it's more important to get on the air with that tornado warning. I'll have my tie on. I mean, there's been instances where I don't have a tie on. I'll just have a shirt and, you know, I'll throw on a microphone and go on, because I think it's more important to get on the air and get the information out than it is to look pretty. I mean, hopefully I'm not that ugly anyway, but, you know, with a tie and makeup and hair, it comes out a little bit better sometimes. But, you know, in a hurricane, yeah, I mean, we kept our suits on and our jackets, you know, but there are times where we'll go on the air if we have to go on hurriedly where that doesn't happen. Yeah.
Do you get to choose the weather stations that you use
that you brought?
Yes. You mean like here where we're displaying these four? Yes. And the computer software that we have we have a couple of ways that we can display it. We have our Baron Lynx computer, which is great because we can route everything right through our weather computer. And then we also have the WeatherBug software, which takes the Earth Network's data and displays it. This particular graphic is through the WeatherBug software, and it allows us to sort. What I did here was you can do temperature, wind, gusts, and you can sort them by highest to lowest. So we've got 103 all the way down to 87. All I did was I took the 4 highest wind gusts. But yeah, we're able to, we've got, I don't know how many, we've got dozens of weather stations that we can pick from. For television friendly purposes, we've decided to only show 4 on a screen. So sometimes we'll show 2 or 3 screens of the same thing. But we've got a lot of data stations, a lot of weather stations, a lot of cameras that we can pick and choose from. But yeah, it's all up to us which ones we want to show. Yes.
What is the wind velocity for a microburst? Does it begin at 35, 45?
Well, it's just with a thunderstorm on that particular day. I think that was probably a fairly typical one. Usually around 40, 45 is what we'll see a lot of times out of microburst. We've seen them as high as 60 recorded on there, 65. Some of the bigger storms can put down some big microbursts, and they'll do damage sometimes. We'll get emails and tweets and stuff into the newsroom that say, "Oh, we had a tornado," and then we'll go back and look at the radar, and we don't see any rotation in the thunderstorm. We're like, "Well, you probably just had a microburst." It does damage just the same, but it was not a tornado. It was something else. All right. Well, thank you, everybody. Oh, do you have one question?
Yeah, I'm just curious about coordination with the Weather Service, Hurricane Center, and so forth.
Mm-hmm.
This event coming up. And I remember the story with Bob Ryan at JLA talking a little bit about coordination with Weather Service on a snow event. But I'm just curious a little bit about that, and then also emergency management in terms of coordination as well.
Well, with the Weather Service, the guys in Tampa and Miami, especially like in the case of this storm and in the case of Irma, it was going to strike Collier County. Irma came on shore of Marco Island, which is Collier County. That's served by the Miami Weather Service. We have in our television station, we have to deal with the Tampa Weather Service and the Miami Weather Service, and they're both great to work with. They come once a year to our emergency management office in Fort Myers. The emergency managers from all over Southwest Florida that are free that day, they come too, and once a year we have a session where we kind of talk about things that happened the past year and things that we could do better. And as far as that goes, they're really great to work with. And also in the event of like Dorian, and the same thing with Irma, if it were to come from, say, Fort Lauderdale, Miami, hopefully that doesn't happen. But if it were, that would also be the Miami Weather Service office, because that's Glades County and Hendry County. And they're really good. They send out an email every day. They do web briefings. They are making themselves available to do interviews. If we want to do a television interview with them, they're just, both offices are really great to work with. They're very transparent, especially whenever a storm comes, in what they're doing and their availability to us. All right, thank you.
Thank you, John, and hopefully you won't have to sleep at the studio at all this weekend. Next up is Mark Hoeksema, our chief meteorologist. Mark's been with the company for 19 years, I believe. So a lot of you have probably worked for Mark or seen him on one of our webinars. But he's going to talk a little bit about the macro environment and how to track severe weather events. Where am I going here? All right, here you go.
That's forward.
Yep.
All right, thanks everybody. Nobody's distracted by the weather here. I certainly am distracted by the weather today. A little bit of background. I manage our 24/7 forecast operations at Earth Network, so we're forecasting for clients around the world. We have clients here in Florida. We have some of them here. And so my staff is extremely busy right now. My presentation is focusing on the severe weather climatology. It's meant to give everybody a kind of a look at when and what and how much and the magnitude and frequency of severe weather, when it occurs across the country. I know most people here are from Florida, so I'll try and focus a little bit more on that, but there's some information here you might just find interesting as a weather nerd or something. But I'm going to get into when severe weather is and how it is affected by what season, the geography, and then, some of it is about, what makes it a threat. Different businesses have different threats based, certain weather events, certain severe weather thresholds and things like that. I'm going to get into a little bit of that. I do have a lot of slides here, and I overdid it, and the news warned me. So I'm going to blow through some pretty fast. The good thing is this is going to be available for folks. There are some sources on it, some URLs for references that you might find interesting. This was already mentioned, but we've had essentially, billion-dollar weather disasters are becoming more and more common. There's more people living in the areas that get affected by these disasters. The total cost of these events since 1980 is approaching almost $2 trillion, and we're seeing more and more billion-dollar disasters every year. This is a slide that shows the disasters from last year, and what you can see is it's pretty evenly spread across the U.S. Billion-dollar disasters can occur almost anywhere, and they range from fires in California to winter storms in the Northeast. All these cover any time of the year, severe weather in the spring. So, the U.S. is in a very unique part of the globe where, based on the oceans and the jet stream and things like that, disasters can occur really any time during the year. So far this year, there have been 6 billion-dollar disasters. Interestingly enough, hailstorms, you think that they're pretty innocuous, but they can approach billion-dollar insurance losses for crops and damage to cars and homes with siding getting taken off and things like that. So we've had some severe weather, big flooding, obviously, in the mid part of the country. Everyone's kind of seen that on the news. It actually still continues now. Some of the spring flooding has just gone on for months in some areas. This graph shows the events and the cost, and you can see that frequency of events doesn't always correlate to the costs. The most common are severe storms with high winds, downburst winds, derechos and things like that. A lot of that happens across the mid part of the country, but the most costly events are the tropical cyclones. Of all the damaging storms that we've had over the last 20 years, the top 6 are hurricane related. So, those are the ones that really affect you folks here. This is a kind of a interesting perspective on severe weather reports. You can see that the western third of the country doesn't get a lot of severe weather. It's very much concentrated in the east. Severe weather reports are high wind gusts, hail, tornadoes, and things like that. In Florida, you get a lot along the coast. Those are often high winds or waterspouts. There's not usually a lot of hail in Florida, but there is in the northern parts of the state sometimes, especially in the early spring when strong cold fronts come through and things like that. And this is a graph that shows the insurance losses by county, and you can see that it's very focused along the coast. It's very focused in Florida and Louisiana and Texas, and that's because, as I mentioned, it's the hurricanes that are really causing the damage. And some of the interesting things on there is you can see what things that look to be aligning along rivers, and that's flood damage. You can actually make the outline of the Missouri River and the Mississippi River in there. Flooding and water damage is very expensive, and so it ends up creating a lot of insurance losses. So I'm going to go through the seasons. I'm going to start with the winter. Obviously, it's snowstorms, ice storms. Winter threats in Florida actually are covered in when I talk about more about wildfires. The dry season in Florida is certainly, with a dry cold front coming through, it can get fires going. But as you might expect, in the last 40 years, the winter storm disasters, the billion-dollar disasters, are focused along the eastern coast with the big cities. You get these blizzards, and they're very costly in the winter. This is for perspective on when folks would want to start thinking about and planning. You get out ahead with your severe weather planning. You want to be a couple months ahead. Talking about winter storms, the first snows actually happen over a lot of the country in the Northeast in October. And then gradually, as you get down, the first snows in some of the Southeast states is in November. Now, granted, they might be small snows, but, the first snow is often, in some sense, it's like a catastrophe on commuting around in some of the major cities. We've had some in D.C. that have, basically shut things down with, a half inch of snow on the first snow day. So, familiarizing yourself when severe weather threats can start is important if you're in the process of making planning around, when do I need to be ready? When do I need to start reviewing processes and get everybody tuned in? Here's the average snowfall by county. You can see that almost all the Southeast averages less than a half inch of snow for the year. But there's a big range as you get from the mid-Atlantic northeastward. It goes up into the 60, 70, 80 inches in the interior of New England. And obviously the mountains are a big focus. Lake effect is very visible on this map, downwind of Lake Erie, Lake Ontario. And I zoomed in a little bit on that just to kind of show that, the gradient across from the Appalachians down to like New York City goes over about 100 miles. It'll go from averaging almost near 100 inches of snow down to about 20, 25 inches of snow in the big cities from New York through Washington. And then here's another interesting graph. It's a chart. It's the amount of days with measurable snow. This is important if you're planning, how many events can I expect on average? Some of the planning is around the budget. How often will I need to plow snow? How often do I need to have processes that make sure our businesses stay open, implemented? And in New England, there's 30 to 40 to 50 days of snow with measurable snow every winter or every season. And then it drops off again precipitously as you get to southern Virginia. There's really no snow events, maybe one or two. But again, one or two snow events in North Carolina or Atlanta, they're big. They can shut the city down. Freezing rain is a big threat for folks. Freezing rain events are common down the eastern Piedmont from into northern Georgia up into Pennsylvania, and then across the Midwest. There's a lot of freezing rain, and there's a kind of a maximum from Oklahoma. They get these really cold air masses that move in there, and then the warm air goes over top of it and creates freezing rain. So, freezing rain is certainly, it can be a problem for a number of days. Usually freezing rain events often will span a couple days in those areas. Now I'm going to move on to spring severe weather. What I would say is that Florida, this is the time of year where they would get more of the severe thunderstorm watches, even tornado watches in the spring. The storm track going through the southeast will bring strong cold fronts through. It's early spring essentially in Florida. I'm going to kind of blow through this. You haven't seen many ice jams in Fort Myers there recently?
Not since the NIC, probably.
But this is a big concern in the Northeast. I cover a lot of this. Like I mentioned, the presentation is about the U.S. River flooding is a huge problem. Spring flooding with snowmelt and ice jams. This was a capture I got from this spring showing where the major flooding was going to occur in the spring, and you can see it's really widespread. It covers the lowlands, and it can last for months, flooding fields and homes and businesses that are along the rivers. Another interesting item here is, this is a concern for our utility clients, is when the leaves come back on the trees. They have different thresholds for wind gusts that will essentially, they have a higher threshold when there's no leaves on the trees, and they switch to a lower threshold for wind gust concerns. And so they're always interested in when the foliage is going to, and it does vary. I mean, we've had some late springs recently in the east where it's been cool and the leaves have been a couple weeks later. The leaves coming on the trees have been a couple weeks later, but it's a pretty wide range of when the leaves get going, and that's important for utilities to know. I'm not going to get so much into this. I think John did a good job of talking about how thunderstorms form and how we get severe weather. Certainly in Florida, the convergences, the sea breeze convergences are a big trigger for thunderstorm development. That dominates the spring, the summer severe weather. But across the country, starting in about mid-March, these are some maps that say that show the probability of where severe weather is focused in the different seasons and the probabilities for severe weather. And in the southeast, there's a kind of a maximum for severe weather. It starts in late February and goes through March. It's due to the southern storm track. Strong cold fronts can come through Florida at that time. Warm fronts that have stalled out, maybe across northern Florida, can be a trigger for tornadoes and the like. As we get into April, the maximum starts focusing on Tornado Alley, as you might expect. Into May, the probabilities go up dramatically in the middle part of the country, and it starts spreading to the east. You do see that the probabilities do increase into northern Florida. This is a combination of kind of the summertime sea breezes kicking in, the afternoon convection, developing potentially severe weather. Still get a cold front through once in a while in Florida in May. And then as we head into June, the heat really builds across the country, and there's a lot of wind gust threats that happen. That maximum of where the severe weather is, it moves northward in the plains, and it spreads eastward into the mid-Atlantic and into the southeast. And then as we get into the middle of July, there's a focus for high winds potential. These are downburst winds. We get, like John talked about, downbursts are very common severe weather events along the East Coast. You'll get some storms developing off the Appalachians, and they'll get going and build high into the atmosphere, and then they'll get a downburst. So a lot of the severe weather potential in the eastern U.S. and in the Ohio Valley there is wind and to some extent hail. Just touching briefly on the climatology around tornadoes. This is when the peak is for tornadoes in the U.S. It's in about mid-May where the probabilities get fairly high. One of the things when you look at this, you can't see it very well up there, is that the colors seem to show that it's really high, but the percentages on this is actually, it's about 10 times less likely to see a tornado in Tornado Alley than it is to see hail or high winds. And I think, and that's generally across the country. Hail and high winds are about 10 times more likely as a severe weather event than a tornado. So obviously they're very impactful and they make the news a lot and they certainly cause a lot of damage, but the events are a lot less. This is the peak time of year for hail. It's generally in May too, and it's in Tornado Alley. So, you know, the stretch from North Texas up into southern Nebraska and then off to eastern Colorado is really what is essentially Tornado Alley, western Missouri. And that's where in May, you know, all the tornado chasers go out and chase around storms in that area. And again, as I mentioned, the peak time for high wind gusts is in the middle of June, and it's essentially in the eastern third of the country. There is some correlation. Studies have been done on El Nino and correlated to severe weather. An El Nino pattern creates fewer tornado events, especially in Tornado Alley. Creates more tornado events, and La Nina events create less. So that's certainly something that when we do our spring severe weather outlooks for clients, it factors into, you know, what we're going to expect and where we call for maybe more probabilities for severe weather. Okay, so in summary, peak time for severe weather is May through June across the country. Tornadoes, they peak in Tornado Alley in this period. Again, El Nino and La Nina do affect spring severe weather. We hear a lot about it affecting winter weather, but it does have a correlation to severe weather. And then the large hail events are essentially in the central part of the country. And then obviously, I don't think anyone's here from the West Coast, but there's a very low probability for severe weather west of the Rocky Mountains. One of the things I wanted to touch on is the trends in tornado. This is kind of an interesting graph, and it's, in some sense, it shows a technology, how technology has affected the number of tornado reports that we get. Over the last 20 years, that previous slide there, it's been fairly flat. I mean, there's been some big years and low years, but it averages out pretty flat over the last 25 years for the number of tornadoes across the country. But it does look like you go, well, weather's getting worse because there was hardly any back in the 50s and 60s, and now there's over 1,200 on average. But one of the things that is important in the counting of tornadoes was that the first weather radar network installed in the U.S. was in the 50s, late 50s, and that helped identify more tornadoes and tornado reports. And then Doppler radar came in the early 90s, installed across the country through the 90s. Doppler radar was much better at identifying storms with tornadoes. And then obviously technology made it easier to report events. And so there's a ramp there that's reflected by that installation. So that's why currently we've seen it generally be flat in the average, because we have all this technology now, we have ways to report it, and it's very efficient in identifying how many tornadoes are. Multiple reports can be focused into just identifying it as a one event and things like that. This is an interesting map, the average number of tornado reports in any given state. You can see that Florida is one of the more common states to get tornadoes. The Weather Service calls a waterspout coming ashore a tornado when it comes on shore. So that is one of the main reasons why it ranks as in the top 10 states for tornadoes. You can see that the typical areas of focus for tornadoes are in the tornado alley there. Okay, now moving on to summer. Summer weather threats have a lot to do with people doing outdoor things. I'm going to move through these pretty quick, but essentially lightning, rip currents. Obviously, it's because people are outside, they're hiking, they're out swimming in the ocean, and heat waves have a bigger effect. People are also outside. One of the things to note from this graph is it shows the average fatalities over 10-year and 30-year periods, and 50% of all weather-related deaths are in summer threats. Heat is actually the largest, most average deaths. This is elderly people. Doesn't get a lot of attention. It's interesting to see, though, that it has a much higher rate of deaths compared to hurricanes and tornadoes and some of the other things where you'd think it would be a lot higher. Rip currents is something that's been counted recently. That's a big problem. It's a big problem here in Florida. Identifying rip currents and publicizing how people can identify one and how to get out of them is just starting to become more of a common communication coming out of the Weather Service. And then lightning deaths. What's really good about this is that the 10-year average is showing a decrease by quite a bit from the 30-year average, and I think a lot of it has to do with technology that, like what we have out there. People have a way to know lightning is close, and they know that they need to get into safety. This is just a summary of the things that I talked about. Interesting picture. This is what a rip current looks like from the air. Lifeguards are pretty good at identifying these, but there's a lot of beaches where there's no lifeguards. So there's a lot of hazards being out in the open water, obviously, in a boat. Not hearing lightning and thunder with boat noise and the water noise and the waves is a problem, and that's one of the reasons why there's so many issues with people getting injured or killed when they're on the water or on the beaches. This is just a quick graph on the heat wave fatalities. These happen in the big cities. Heat waves are a big problem. Emergency management, health officials really focus on this in the big cities in the east and in the Midwest. There's also a lot of different heat advisory thresholds that are actually higher in the south than in the north, but the human body actually often has the same effect on heat whether you're in the north or the south. So, there's a number of things that folks that have concerns about people being outdoors at their parks or beaches or in schools playing football. The heat advisories for the Weather Service are focused on the heat index, but wet bulb globe temperature is something that everybody should start to tune in on. It's becoming more and more common to hear that people have processes around that. And then a couple quick slides on drought and severe weather. Wildfire threats are mostly in the west, but you do see in Oklahoma there's a maximum, and also in Florida there's a maximum. A lot of it has to do with, if Florida's in a drought situation and there's dry cold fronts coming through, there's a lot of open land that can start burning in Florida. It's the same thing in Oklahoma and parts of the Midwest there. You hear mostly about the fires in California, and if you look at where structures are lost, you can see it is focused on California, Texas, and Oklahoma, but there also are a number of interior. It's usually the interior areas of Florida that have gone into a drought situation when the wildfire threat becomes a problem in Florida. Air quality is another thing that's becoming more and more important. I'll just touch on that. This is something that everybody should understand. You know, when is the bad air quality times in their areas? More and more urban pollution, obviously, with building out of cities, it becomes fairly regular to have moderately bad air quality days. You don't need really bad air quality days to cause problems with the elderly and the young folks who are playing outside and things like that. Now I'm going to just talk about some of the fall threats. It's tropical storms and hurricanes. This is a graph of the averages of tropical storms and hurricanes over the course of a year, and I put the arrow on today, and interestingly enough, there is a massive increase in the numbers that happens right around this time. And the tropics have really heated up. It was just a week or two ago, as John mentioned, there's Saharan dust that was suppressing a lot of activity across the Atlantic, and things kind of have flipped. And so now there's, you know, potential for these waves coming off of Africa to start really getting going. And we've seen that with 2 active storms going right now, and another one potentially coming off of Africa later next week that will have to be watched. But between now and essentially mid-October is when 2/3 of all the hurricanes that will occur. This is an interesting map that I like to show. It's all the storm plots, and it gives you a really good idea of what climatology is, but you can also see that only a fraction of storms actually hit the U.S. Based on, you know, our geography and how the jet stream works. But it essentially it shows that, you know, hurricanes are a big concern, but, you know, we're fortunate that most of them often turn away from the coast here. Certainly the Windward Islands and the Caribbean gets hit by a lot of them. You can see a lot of major storm tracks there in that area. This is also an interesting chart for folks here. This is hurricane landfalls since 1950. One of the things of note is that in the area with the highest probabilities for where the Hurricane Center thinks Dorian's going to come ashore, there is a definite minimum from about Fort Pierce up through Fort Lauderdale. And so that's unusual because the Florida coast tips in there, and the jet stream often moving across the central U.S. will pull storms away, but it would be an unusual occurrence to get a landfalling hurricane in that region as it is currently being forecasted. And again, these are good maps to show. Here we are in August. You can see most likely places for storms. Dorian pretty much is deciding that it's going to be a most likely track. It's essentially formed where that shows it would, where it's most likely, and its probable track is trending in that direction too. And then obviously September is very active, and then it tails off. But you can see that Florida has a late season probability, where in the Western Caribbean, those are the storms that often come into the Gulf and then will turn toward the west coast of Florida and track across Florida from that direction. Again, most of the deaths are from water. It's the surf, it's the rain, and the storm surge. Water is extremely powerful. 88% of all fatalities have to do with water-related hazards. Fog, I wanted to cover everything, and fog is a threat to transportation, travel, and shipping. You don't think of it as a threat, but it affects airline travel immensely. Fall is the big time for fog days, and they're often concentrated along the Gulf Coast and up into the Appalachians in the Northeast. It will affect trucking, a lot of that sort of stuff gets affected by fog. And I think I was a little bit long, but does anyone have any questions? Start there.
What was the alternative to the heat? Excuse me. What was the alternative to heat index that you were?
Oh, that's the wet bulb globe temperature. Yeah, so the wet bulb globe temperature is something that's been gaining popularity because it's a little bit more realistic index that can help you with understanding heat stress on people that work outside, because it factors in the direct sunlight with somebody, and it also uses the wind speed. Wind speed, John mentioned that wind speeds can dissipate heat off you, but if there's no wind and you're in the direct sun and you have high humidity, high temperatures, there's an index for that. It's certainly worth looking up and reading about. We have a whole system that can be deployed with wet bulb globe temperatures. In fact, we have a bunch of people here that I think might be using it that you could talk to about it. It was developed in the military, and now it's progressing into more private industry.
A little more on the wet bulb versus heat index. How close do you think they are to each other?
Well, they're.
I thought wet bulb was more accurate, but either you have to, what I think, and I might be wrong, you either have to have a very expensive meter or you've got to use a swingometer and do some calculations on graph. The reason I'm asking, we were from a school district, and the Florida High School Athletic Association requires the trainers, they're supposed to be taking wet bulb readings and then determine whether the athlete should get off the field or not. But to me, it seems a little unrealistic to get those trainers out in the field, with a thermometer and a calculator.
Well, having a.
The heat index, we've been telling them to go by heat.
Well, they're both accurate in the sense that as long as you're taking the measurements accurately, someone using one of those handheld things may not take it accurately, and there's human error involved with that. An automated system that measures everything and then calculates it and lets you know on wet bulb globe temperature is certainly the better way to go. You'll get a consistent value. The wet bulb globe temp can change a lot. A cloud can go in front of the sun, the wind can drop off, the wind can gust. Having an automated sensor where you can kind of see how it's been trending and take an average, you can have processes around what level that is. You shouldn't really focus on that. There might be a difference between the numbers, because the numbers are just supposed to trigger a process. So there's certain numbers with wet bulb globe temperature that might be lower that are triggering the same process that a heat index is doing at a higher level. But again, we have all kinds of information on wet bulb globe temperature. We can certainly provide, and it'll help you educate yourself on that.
Did you say you have sensors that are available with the weather system?
Yes.
And if you just need to put that spot for a minute and ask for opinion. Without those sensors, would a trainer standing out in the field with one football player be better off going by the automated heat index he's getting across his alert text, or staying out there and trying to use this thermometer or this method?
To me, it's more efficient to just have the system running and pushing an alert to you than making somebody who has other things on their mind try and operate, hold up the globe sensor and read it, and then, were they in the right spot? Was it a good spot for the measurement? I mean, there are leagues that have it that you're supposed to go out to the 50-yard line and stand there and hold it at 10 feet or something and take a measurement. Right. And wet bulb globe temperature can be regionalized a little bit. Having a reading from a location that's a little distance away can be representative for the area based over a period of time, because, like I mentioned, wind changes rapidly, clouds come in, change rapidly. Those values are going to bounce around, and so it's more about kind of averaging it out over time and space, and then having your own process on what number is going to trigger. There's all kinds of stuff published on what you should do. OSHA, Cal OSHA, they all have their own, like how many minutes you need to rest, water breaks, all that stuff. There was a question over there. Yes?
Mine's a fun question. I love your maps. It shows all kinds of weather. What state has the least weather challenges?
That if you quantify it by severe weather reports, it's Montana.
Which has the high suicide trade one for the other.
Everyone's got, yeah, there's always something. But, I think you would see on that map, it was a number of slides, and you can reference it, is that, if you just go by severe weather reports, it's, Southern California and Nevada and up through, not many people live there, so it's like maybe the reports aren't quite as efficient. But, Southern California has fires. They have Santa Ana wind problems, earthquakes, not counted. That's why I would say it's probably more like, Montana gets really cold weather, but they don't see as much of the other stuff.
Excellent. Thank you very much.
Yep.
All right. Thanks, Mark. Good stuff. All right, so we're going to break for about 15 minutes now. Just for so everyone knows, the restrooms are outside and all the way down on the left, if you need to use those. And we know some people may need to leave early at some point today. If that happens, we do have some swag to give you guys all today. If you happen to be leaving, come by. They're sorted by size, so let one of us give it to you. But just wanting to let you know that's available if anybody has to leave. All right, see you in 15.